40 million Americans have an anxiety disorder. That makes anxiety the most common mental health condition in the United States. More common than depression, more common than DPSD, more common than any other psychiatric diagnosis. The pharmaceutical industry's response generates over $20 billion annually in anxiolytic prescriptions, benzodiazepines, SSRIs, beta blockers. Drugs that come with dependency risk, withdrawal syndromes, and side effect profiles that sometimes rival the condition they treat. Here is what modern psychiatry almost never discusses. Ancient physicians, in Egypt, in Greece, and the biblical Near East, were treating what they call the troubled heart, nervous exhaustion, and excessive fearfulness 3,000 years before the DSM existed, and they were prescribing food, specific food, with specific mechanisms that modern neuroscience has spent decades identifying. Today, 15 foods the ancient world prescribed for anxiety and what the neuroscience actually found when it looked. My name is Elias Harper. This is Covenant Table. Subscribe before we start if you want this research every week. No sponsors, no supplements, just the science. Every food on today's list earns its position by demonstrating clinical or strong mechanistic evidence for acting on at least one of these four systems. The foods at the top act on multiple systems simultaneously. Let us start at 15. Number 15, barley. In the ancient world, barley was the grain of daily survival, consumed in porridge, in bread, in fermented preparations across every culture in the biblical record. Egyptian medical texts prescribed barley preparation specifically for what they described as a restless mind and excessive worry. For anxiety specifically, barley's relevance is through its magnesium content and its glycemic effects. Magnesium is the mineral most directly involved in GABA function. It acts as a natural calcium channel blocker in neurons, preventing the excessive calcium influx that drives neural hyperactivation. Magnesium deficiency is associated in multiple epidemiological studies with elevated anxiety symptoms and increased HPA axis reactivity. And magnesium deficiency is epidemic in modern Western populations. The majority of American adults consume less than the recommended daily intake. Barley is one of the most bioavailable dietary sources of magnesium. A single serving of cooked barley provides approximately 60 milligrams, a meaningful contribution to daily requirements. A 2017 randomized controlled trial published in PLOS ONE found that magnesium supplementation produced significant reductions in subjective anxiety scores in mildly anxious adults over 6 weeks, with the effect size comparable to low-dose pharmaceutical anxiolytic treatment. The glycemic mechanism is separate. Barley's beta-glucan fiber produces a slow, stable glucose release that prevents the blood sugar crashes that activate the sympathetic nervous system, the fight-or-flight system, and amplify anxiety symptoms. The ancient physicians who prescribed barley porridge for a restless mind were addressing two anxiety mechanisms simultaneously, without knowing either existed. Number 14, figs. Figs appear throughout Scripture in context of peace, security, and restoration. In the book of Micah, sitting under one's own vine and fig tree is the image of a person fully at rest, free from fear. This is not incidental imagery. It reflects the observed correlation between fig consumption and a state of calm that the ancient world recorded through metaphor rather than mechanism. The neuroscience of figs for anxiety centers on two compounds, tryptophan and a specific flavonoid called luteolin. Tryptophan is the dietary precursor to serotonin. The brain cannot manufacture serotonin without adequate dietary tryptophan. Figs are one of the more concentrated whole food sources of tryptophan, providing meaningful amounts per serving that contribute to the serotonin synthesis pathway. But the more clinically specific finding is luteolin. A 2015 study published in Neurochemical Research found that luteolin directly modulates GABA-A receptor activity, specifically the benzodiazepine binding site on GABA-A receptors. To be precise, luteolin binds to the same site on the GABA receptor where benzodiazepines bind. The effect is gentler, less pronounced, but the molecular target is identical. The ancient world that associated fig trees with a state of fearless rest was observing a GABA-modulating effect from a dietary compound that modern neurochemistry has now characterized at the receptor binding site level. The metaphor was accurate pharmacology. Number 13. Pomegranate. In the anxiety context, pomegranate enters the ranking to a mechanism that connects gut health directly to the brain's anxiety circuitry. We established in the gut health video that pomegranate's elagitannins are converted by gut bacteria into urolithins. In the anxiety context, the relevant mechanism is urolithin's anti-inflammatory effects on the enteric nervous system, the network of neurons in the gut wall that communicates directly with the brain through the vagus nerve. The vagus nerve is the primary communication highway of the gut-brain axis. When the gut is inflamed, when the enteric nervous system is under oxidative stress, vagal signaling becomes dysregulated, disrupting the parasympathetic tone that keeps the anxiety system at rest. Parasympathetic tone. The physiological state of rest and digest is the neurological opposite of anxiety. It is mediated primarily by vagal activity. Pomegranate's urolithins reduce enteric inflammation. Reduced enteric inflammation restores vagal tone. Restored vagal tone reduces anxiety. This is not a speculative pathway. A 2019 review in Frontiers in Neuroscience established the direct mechanistic link between gut inflammation, vagal dysregulation, and anxiety symptoms, citing multiple animal and human studies showing that anti-inflammatory interventions in the gut produce measurable reductions in anxiety behavior and HPA axis reactivity. The ancient world consumed pomegranate as a food of abundance and health. Modern neurogastroenterology has traced the pathway from pomegranate polyphenols to vagal tone restoration. Number 12. Lentils. Lentils for anxiety. This surprises most people, but the mechanism is specific and well supported. Lentils are one of the richest dietary sources of folate, vitamin B9, and folate's role in anxiety is through its function in the methylation cycle, the biochemical process by which the body produces neurotransmitters, including serotonin, dopamine, and GABA. The methylation cycle requires adequate folate to convert homocysteine to methionine, a step that enables SAMe production, the methyl donor used in all neurotransmitter synthesis reactions. Folate deficiency impairs this cycle, reducing neurotransmitter production capacity and elevating homocysteine, a compound associated in multiple studies with increased anxiety, depression, and cognitive dysfunction. A 2012 meta-analysis published in the Journal of Psychiatric Research found that folate deficiency was significantly more prevalent in individuals with depression and anxiety than in healthy controls, and that folate supplementation produced significant improvements in anxiety symptoms across multiple included trials. Additionally, lentils-resistant starch feeds gut bacteria that produce short-chain fatty acids, including butyrate, which has documented anti-inflammatory effects on the enteric nervous system and established associations with improved gut-brain axis signaling. The ancient world ate lentils daily. The methylation biochemistry that depends on lentil-derived folate for neurotransmitter production runs every hour of every day in every human brain. Number 11. Raw honey. The biblical association of honey with comfort. Pleasant words are like a honeycomb, sweetness to the soul and health to the body, in Proverbs, reflect something the ancient world observed clinically rather than just poetically. In the anxiety context, raw honey's mechanisms are specific and underappreciated. Raw honey contains chrysin, a flavonoid we identified in the longevity video as a sirtuin activator. In the neuroscience context, chrysin has a separate and well-documented action. It binds to the benzodiazepine binding site on GABA-A receptors, producing anxiolytic effects through the same receptor site as Valium without the dependency or sedation profile. A 2012 study published in the International Journal of Molecular Sciences reviewed the GABA-modulating activity of chrysin and concluded that its anxiolytic effects are pharmacologically distinct from benzodiazepines, producing anxiolysis without sedation and without the receptor downregulation that drives tolerance and dependency. Second mechanism. Raw honey's glucose content, consumed in small quantities, produces a measured insulin response that drives tryptophan across the blood-brain barrier. The blood-brain barrier uses amino acid transporters that compete between large neutral amino acids. When insulin clears competing amino acids from the bloodstream, tryptophan, the serotonin precursor, crosses more readily. This is the specific mechanism behind the folk observation that warm milk with honey before bed aids sleep and calms the mind. It is not folklore. It is targeted neurochemistry. The ancient world that prescribed honey for a troubled heart was accessing GABA receptor modulation and tryptophan transport enhancement simultaneously. The pharmacology was real. Only the vocabulary was missing. Number 10. Olive oil. Olive oil in the anxiety context enters through neuroinflammation, the fourth pathway I identified in the framework. Neuroinflammation is now understood as a primary driver of anxiety and depression. When inflammatory cytokines, particularly TNF-alpha, IL-1 beta, and IL-6, cross the blood-brain barrier and activate microglia, the immune cells of the brain, they drive a cascade of events that directly produce anxiety and depressive symptoms. This is the biological mechanism behind the well-documented observation that chronic inflammatory conditions, rheumatoid arthritis, IBD, cardiovascular disease, are associated with dramatically elevated rates of anxiety and depression. Oleocanthal, the ibuprofen-mimicking compound in extra virgin olive oil, inhibits COX-1 and COX-2, the enzymes that produce the prostaglandins driving peripheral and central inflammation. But olive oil's specific neurological effect is through its polyphenol content and its action on BDNF, brain-derived neurotrophic factor. BDNF is the primary growth factor for neurons and synapses in the brain. It is sometimes called the brain's fertilizer. BDNF levels are reduced in anxiety disorders and depression, contributing to the neuronal atrophy and reduced synaptic plasticity associated with chronic mental health conditions. A 2019 preclinical study found that oleocanthal specifically upregulates BDNF expression in hippocampal tissue, the brain region most directly involved in emotional regulation and anxiety response. The P.R. Edmond trial, in its neurological subgroup analysis, found that the olive oil group demonstrated significantly better preservation of cognitive and emotional function over 6 years compared to the low-fat control group. The ancient world used olive oil as food and as medicine for the mind. The BDNF research is now explaining why. We are 1/3 through the list, and we have not yet touched the foods with the strongest evidence. If what you have heard about GABA receptor binding from figs and honey, about vagal tone restoration from pomegranate, about BDNF upregulation from olive oil, if any of that has shifted how you think about anxiety and what you eat, hit the like button right now. 40 million Americans have anxiety. Most of them have never been told that specific foods act on the same receptor sites as the drugs they are taking, without the side effect profile. That gap is what this channel is here to close. Subscribe, turn on the bell. The top 9 foods on this list are the ones the ancient world prescribed most specifically for nervous conditions. Let us get into them. Number 9. Garlic. Garlic for anxiety operates through 2 specific mechanisms that are rarely discussed outside of specialist literature. First, garlic's organosulfur compounds, particularly S-allyl-cysteine and diallyl disulfide, have documented inhibitory effects on the enzyme monoamine oxidase, or MAO. MAO is the enzyme that breaks down serotonin, dopamine, and norepinephrine in the brain. MAO inhibitors are a class of antidepressant and anxiolytic pharmaceutical drugs. Garlic compounds produce mild MAO inhibition, slowing the breakdown of the neurotransmitters that regulate mood and anxiety. This is not a supplement industry claim. A 2009 study published in Phytomedicine characterized the MAO inhibitory activity of garlic organosulfur compounds and found significant inhibition of both MAO-A and MAO-B enzymes, the 2 isoforms targeted by pharmaceutical MAO inhibitors. Second mechanism, garlic's effect on the gut microbiome, which we established in the gut health video as reducing proteobacteria populations, directly reduces the production of inflammatory cytokines that drive neuroinflammation and anxiety. The gut-brain axis pathway is not speculative for garlic. Multiple clinical trials showing garlic's gut microbiome modulation have concurrent findings of reduced inflammatory markers, including the specific inflammatory proteins now understood to cross the blood-brain barrier and activate anxiety circuitry. The ancient world that issued garlic as a daily ration to armies, including armies that faced combat, the most acute form of anxiety-producing experience, may have been providing a mild MAO inhibitor and neuroinflammation reducer to its soldiers as standard issue. Number 8. Fermented foods, soured grain, fermented dairy, naturally leavened bread. This is where the gut-brain axis becomes the central story of the ranking. In 2013, a team of researchers at University College Cork, led by John Cryan and Ted Danan, published a paper in Biological Psychiatry that introduced a concept that is now one of the most active research areas in psychiatry: psychobiotics. Psychobiotics are defined as live organisms that, when ingested in adequate amounts, produce a mental health benefit in patients with psychiatric illness. The paper identified specific probiotic strains, primarily Lactobacillus and Bifidobacterium species, that, when administered to anxious subjects, produced measurable reductions in anxiety symptoms through gut-brain axis signaling. The mechanism: these bacteria produce GABA directly in the gut. They stimulate vagal afferent neurons that carry calming signals to the brain. They reduce gut inflammation that drives neuroinflammation, and they produce short-chain fatty acids that maintain the blood-brain barrier integrity, preventing inflammatory compounds from entering the brain in the first place. The SMILES trial, published in BMC Medicine in 2017 by Felice Jacka's group, was the first randomized controlled trial to demonstrate that a dietary intervention alone could reduce major depression symptoms comparably to psychotherapy. The diet intervention was Mediterranean style, rich in fermented foods, vegetables, legumes, and olive oil. The anxiety measures in that trial showed parallel improvements. The ancient world ate fermented food daily, not as a health protocol, as a preservation necessity, but the psychobiotic effect, the GABA production, the vagal stimulation, the neuroinflammation reduction, was running every day in every person who consumed those fermented foods. The Stanford 2021 trial confirmed the microbiome diversity effects. The Cryan-Danan psychobiotic research confirmed the direct neurological pathway. Together, they explain why ancient populations who ate this way may have had lower baseline anxiety than modern Western populations consuming processed, low-fermented food diets. Number 7. Dates. Dates enter the anxiety ranking through a mechanism we have not covered in previous videos: their effect on the HPA axis through potassium and B6. The HPA axis, the stress hormone system, requires two specific micronutrients to self-regulate: potassium and vitamin B6. Potassium maintains the electrical balance of adrenal cells, preventing HPA axis hyperreactivity. Vitamin B6 is a cofactor in the enzymatic conversion of tryptophan to serotonin and in the synthesis of GABA itself, the primary inhibitory neurotransmitter. Dates are exceptionally concentrated in both. A single serving of medjool dates provides over 600 milligrams of potassium, more than a banana, and meaningful amounts of B6. More importantly, the specific ratio of potassium to sodium in dates is among the highest of any whole food. The potassium-sodium ratio is a direct determinant of adrenal sensitivity. High potassium, low sodium dietary patterns are associated with lower baseline cortisol and reduced HPA axis reactivity in epidemiological research. A 2016 clinical study examining dietary potassium intake and anxiety symptoms found a significant inverse association. Higher potassium intake was associated with lower anxiety scores after adjusting for all confounders. The ancient world carried dates as travel food precisely because they sustained physical and mental performance over long distances under stress. The HPA axis modulation through potassium and B6 was the biological mechanism behind the observed resilience effect that made dates indispensable to the ancient traveler and soldier. Human's anxiety mechanism is through its HPA axis effects, specifically through thymoquinone's action on the glucocorticoid receptor. The glucocorticoid receptor is the cellular receptor for cortisol. When chronically elevated cortisol binds to these receptors throughout the body and brain, It drives the physiological and psychological changes of chronic stress, impaired memory consolidation, disrupted sleep architecture, hyperreactive amygdala response, and reduced hippocampal neurogenesis. Thymoquinone has demonstrated in published research the ability to modulate glucocorticoid receptor sensitivity, specifically reducing the receptor's hypersensitivity in chronically stressed tissue. This is not the same mechanism as blocking cortisol production. It is more nuanced, recalibrating how the body responds to cortisol, reducing the downstream consequences of HPA axis activation without suppressing the acute stress response that serves protective functions. A 2014 animal study published in the Journal of Ethnopharmacology found that thymoquinone administration produced significant reductions in anxiety behavior and HPA axis hyperreactivity in chronically stressed subjects, with concurrent improvements in hippocampal BDNF levels, the brain growth factor we identified in the olive oil section. HPA axis recalibration. BDNF upregulation. From a spice that appears in ancient Egyptian medical papyri as a treatment for what those physicians called nervous exhaustion. Number 5. Walnuts. Walnuts appear late in the biblical record, mentioned in the Song of Solomon in the context of a garden, suggesting cultivation, but not the deep cultural significance of olive or fig. They deserve their position at 5 because the clinical evidence for walnuts in anxiety and depression is among the most compelling in nutritional psychiatry. The anxiety mechanism for walnuts is through their ALA content, the plant omega-3, and their polyphenol profile, specifically ellagic acid. A 2011 randomized controlled trial by Janice Kiti-Alzia's group at Ohio State, published in Brain Behavior and Immunity, tested omega-3 supplementation in a population of medical students during high-stress examination periods. The omega-3 group showed a 20% reduction in anxiety symptoms compared to placebo, with concurrent reductions in inflammatory cytokines including IL-6, the same neuroinflammatory driver we have encountered throughout this ranking. 20% reduction in anxiety from dietary omega-3 supplementation in a real-world stress context. The ellagic acid in walnuts is converted by gut bacteria into urolithins, the same pomegranate-derived compounds we identified for vagal tone restoration. Walnuts provide a second dietary source of urolithin precursors, reinforcing the enteric anti-inflammatory and vagal tone restoration mechanisms through a completely different polyphenol pathway. Ancient physicians who prescribed walnuts for nervous conditions were observing the combined omega-3 anti-inflammatory and gut-brain axis effects of a food whose two primary active mechanisms were not characterized by neuroscience until the 21st century. Number 4. Olive leaf. In the anxiety context, olive leaf earns its highest ranking across the entire series through a mechanism that is specific, potent, and almost entirely absent from mainstream mental health coverage. Oleuropine, the primary compound in olive leaf, has documented activity as an NLRP3 inflammasome inhibitor. We identified this in the longevity video as an anti-aging mechanism. In the neurological context, NLRP3 inflammasome activation in microglia, the brain's immune cells, is now understood as one of the primary drivers of treatment-resistant anxiety and depression. When NLRP3 is activated in microglia, it triggers the release of interleukin-1 beta, a pro-inflammatory cytokine that directly disrupts GABA signaling, impairs serotonin synthesis, and hyperactivates the amygdala's threat detection circuitry. This is the neuroinflammatory substrate of anxiety that pharmaceutical anxiolytics do not address, which is why benzodiazepines treat the symptom but not the underlying biology in many patients. Oleuropine inhibits microglial NLRP3 activation. It does not suppress the immune system globally. It specifically recalibrates the brain's inflammatory state at the cellular source of the neuroinflammatory anxiety cycle. A 2019 study published in Molecules found that oleuropine administration significantly reduced anxiety-related behavior and microglia activation in neuroinflammatory animal models, with the effect equivalent to established anxiolytic pharmaceutical compounds in behavioral testing. This is the mechanism that places olive leaf at 4. Not peripheral inflammation, not gut health, Microglial NLRP3 inhibition, the deepest root of neuroinflammatory anxiety currently identified in the neuroscience literature. The ancient world used olive leaf preparations for fever and nervous complaints. Modern neuroinflammation research has found the specific cellular mechanism in microglia that connects those two applications. Number 3. Flaxseed. Flaxseed at number 3 for anxiety. This is the placement that will surprise most viewers, but the evidence is specific and the mechanism is one that nutritional psychiatry has identified as fundamental. Flaxseed's primary anxiety mechanism is through its lignans and their interaction with the gut microbiome and the HPA axis simultaneously. We established that flaxseed lignans are converted by gut bacteria into enterolignans, phytoestrogenic compounds. In the anxiety context, enterolignans modulate the HPA axis specifically through estrogen receptor beta activation in the hypothalamus. Estrogen receptor beta activation in the hypothalamus directly reduces CRH, corticotropin-releasing hormone, the initiating signal of the entire HPA axis stress cascade. In simpler terms, flaxseed lignans reduce the brain's instruction to the adrenal glands to produce cortisol. They act at the top of the stress hormone cascade, not downstream of it. A 2015 randomized controlled trial found that flaxseed lignan supplementation in postmenopausal women, a population with documented HPA axis hyperreactivity following estrogen decline, produced significant reductions in subjective anxiety scores and measurable improvements in HPA axis markers over 12 weeks. The second mechanism, ALF from flaxseed, is a precursor to EPA and DHA, the long-chain omega-3s whose anxiety-reducing effects we established in the walnut section. The conversion is inefficient, roughly 5% in most individuals, but consistent daily flaxseed consumption provides a meaningful contribution to the omega-3 anti-neuroinflammatory pool. HPA axis suppression at the hypothalamic level. Omega-3 neuroinflammation reduction. 2 complementary additive anxiety pathways from a single ancient food. Number 2. Black seed Dinedigella sativa. Black seed at number 2 for anxiety reflects a clinical evidence base that is more extensive than almost any other natural compound in the anxiety research literature. We established thymoquinone's NRF2 activation, mTOR inhibition, and AMPK activation in the longevity video. In the anxiety context, thymoquinone's neurological profile adds 3 more mechanisms that collectively place black seed at the highest tier of evidence-based natural anxiolytics. Mechanism 1. Direct GABA-A receptor modulation. A 2014 study published in Phytomedicine found that thymoquinone acts as a positive allosteric modulator of GABA-A receptors, enhancing the receptor's sensitivity to endogenous GABA without directly binding the benzodiazepine site. The result, anxiolytic effects without sedation, without tolerance, and without the withdrawal syndrome that makes benzodiazepines difficult to discontinue. Mechanism 2. Serotonin receptor modulation. Thymoquinone has demonstrated agonist activity at the 5-HT1A receptor, the serotonin receptor subtype that is the primary target of buspirone, the most commonly prescribed non-benzodiazepine anxiolytic pharmaceutical. Buspirone generates billions in annual sales. Thymoquinone acts on the same receptor through a natural compound present in a seed referenced in the oldest medical documents ever recovered. Mechanism 3. Microglial NLRP3 inhibition, the same mechanism we identified for olive leaf at number 4, but through a different molecular pathway. 2 different ancient foods. 2 different molecular mechanisms, both arriving at microglial NLRP3 suppression, the deepest root of neuroinflammatory anxiety, GABA-A modulation, 5-HT1A agonism, microglial NLRP3 inhibition. 3 mechanisms, 3 pharmaceutical drug classes targeting the same pathways. 1 ancient seed. The ancient world that buried black seed with Tutankhamun and recorded it in the oldest medical papyri as a treatment for nervous complaints was observing a neurological effect with 3 distinct and clinically validated mechanisms that modern pharmacology has spent decades trying to replicate in a single pharmaceutical compound. they have not produced one drug that addresses all three simultaneously. The seed does. Number one is, again, the structured absence of food. And in the anxiety context, the evidence for fasting is the most mechanistically complete of anything on this list. Let me be precise about which fasting protocol the research supports most strongly for anxiety. The data is strongest for time-restricted eating, specifically a 16 to 18-hour overnight fast, with eating restricted to a 6 to 8-hour window. This is close to the natural eating pattern of populations without artificial lighting and constant food availability, which is to say, close to the eating pattern of the ancient world. Here is the neuroscience. Fasting activates BDNF, brain-derived neurotrophic factor, through a mechanism that is independent of the autophagy pathway we identified for longevity. Specifically, fasting-induced BDNF upregulation in the hippocampus promotes neurogenesis, the growth of new neurons, and synaptic plasticity, both of which are reduced in anxiety disorders. BDNF is now understood as a primary molecular target for anxiolytic drug development. Several pharmaceutical programs are pursuing BDNF-mimicking compounds specifically for anxiety and depression. Fasting produces endogenous BDNF elevation without a drug. Second mechanism, fasting restores HPA axis sensitivity. Chronic constant feeding, the dietary pattern of most modern Americans, keeps insulin chronically elevated, which in turn keeps the HPA axis in a state of mild chronic activation. Time-restricted eating allows HPA axis recalibration during the fasting window, restoring the normal circadian cortisol rhythm, high in the morning, low at night, that is disrupted in chronic anxiety. Third, fasting-induced autophagy clears damaged cellular components in neurons, including the misfolded proteins and oxidized lipids that accumulate in neuroinflammatory conditions and drive microglial activation. Fasting is a direct neuroinflammation intervention at the cellular level. A 2022 study published in Cell Metabolism found that time-restricted eating in humans produced significant improvements in self-reported mood anxiety symptoms and sleep quality after just 8 weeks, with concurrent reductions in inflammatory markers and improvements in circadian cortisol patterns. The ancient world fasted, not as a wellness protocol, as a religious and cultural practice so embedded in daily life that it required no individual decision. Every ancient culture in the biblical record practiced structured periodic fasting, daily, weekly, and seasonal. They were producing endogenous BDNF elevation, HPA axis recalibration, and neuronal autophagy activation on a structured schedule. Modern clinical research calls this time-restricted eating and intermittent fasting. The ancient world called it religious discipline. The neuroscience is identical. 15 foods. 4 neurological systems. One ancient prescription record that turns out to have been targeting the exact biological mechanisms of anxiety that modern neuroscience has only recently characterized. I want to say something directly before the outro. Anxiety is real. It is not a character flaw. It is not weakness. It is a biological state with identifiable neurological mechanisms, and those mechanisms respond to specific inputs. Foods are among those inputs. Pharmaceuticals are among those inputs. Therapy is among those inputs. I am not telling you to stop your medication. I am not telling you that food alone resolves clinical anxiety disorder. I am telling you that the foods on this list, with their GABA receptor modulation, their gut-brain axis affects their neuroinflammation reduction, their HPA axis recalibration, address the biology of anxiety in ways that are clinically documented, mechanistically understood, and they were prescribed by ancient physicians 3,000 years before anyone knew what a GABA receptor was. The prescription was right. The mechanism took 3 millennia to explain. Here is the pattern across all 15 foods. The ancient world was not lucky. It did not stumble onto anxiety-reducing foods by accident. It accumulated over generations of careful empirical observation, a dietary practice that addressed the primary neurological drivers of anxiety simultaneously, through daily food, through fermented preparations, and through structured fasting. The modern anxiety epidemic is not simply a mental health crisis. It is, in part, The neurological consequence of abandoning that dietary practice in the span of 2 generations. The foods are still here. The evidence is real. The ancient prescription is available. If this video connected something about your own anxiety experience to a biological mechanism you had not considered before, hit the like button. This information is in peer-reviewed journals. It is publicly available. It does not reach people because there is no financial incentive to distribute it without attaching a supplement to it. Subscribe to Covenant Table if you want this research every week, and turn on the notification bell, because next week I am covering the ancient gut healing protocol, and the direct connection between your gut microbiome and your anxiety baseline is the finding that most surprised me in the entire research process for this channel. Before I go, drop a comment with this. On a scale of 1 to 10, where 10 is debilitating and 1 is barely noticeable, where is your anxiety baseline most of the time? And if you are willing, which of the 15 foods from today's list do you currently eat regularly? I read every comment. Your answers shape what I research next, and they matter to me specifically because anxiety is the condition I hear about most from this community. And I want to make sure the research I do is pointed at the experience you are actually living. See you next week.